Alright, remember that Pythagorean triples are a set of three positive integers, and we remember that integers are basically whole numbers that satisfy the Pythagorean theorem, a squared plus b squared equals c squared, where c is the hypotenuse and a or b are the legs of a right triangle. So in the 1939 movie The Wizard of Oz, when the Scarecrow got his doctorate in thinkology, which is not a real degree, do not try and go get, he said the sum of the square roots of any two sides of an isosceles triangle is equal to the squares of the remaining sides. Did he get the Pythagorean theorem right? No, he screwed it up majorly. What did he mess up? Well, it's the sum of the squares of the two legs of a right triangle is equal to the square of the hypotenuse, which I guess is the remaining side. So quite a few mistakes there. Number 2 in the back here, if we just use the Pythagorean theorem, it's p squared plus q squared equals r squared, r being our hypotenuse, so a is true, so b can't be. Now if I subtract q squared from both sides, I get this equation, which is exactly what c is, so that's fine. We need to know that this is not equal to this. You don't just distribute that. That's not true. So D isn't true, and E, we can't rearrange them to get it that way either. So A and C are the only ones that are true. Find the unknown length. So number 3, here's our work. We're looking for the hypotenuse, so it's 1 squared plus 2 squared equals x squared. That's 1 plus 4 equals x squared. That's 5. Take the square root. We can't break down 5 anymore, so it's the square root of 5. Number 4, it's a triple. If we factor out common denominator, or a common factor, GCF if you will, 2, you got 4 times 2, 5 times 2, so we're looking at our 3, 4, 5 family, so this has to be 3 times 2 or 6. Or, if you don't remember, use Pythagorean theorem. Our hypotenuse is the 10, so that's on the side of the equal sign by itself. So x squared plus 8 squared equals 10 squared, which is x squared plus 64 equals 100. Subtract 64, x squared equals 36, square root it up, x equals 6. Number 5, 4 and 8. If we look at 2 times 2, 4 times 2, 4 and 2 aren't part of any triples, so we're not using triples on this, we're just doing Pythagorean theorem, and we're trying to find one of the legs now. So 4 squared plus x squared equals 8 squared. That's 16 plus x squared equals 64. Subtract 16 from both sides, we get x squared equals 48. We'd have to take the square root, and we want to simplify. We can break it down. We can take out a pair of 4s. We get 4 root 3. Or we can break it down even more, and what we end up getting is 4 2s and a 3. So take out 2 2s, which gives us the 4 as well. Number 6. Can we use the right triangle altitude theorem or geometric mean? No, because this isn't a right angle up there. So we can't do that. So if we look at this right triangle, it's a 3, 4, 5 right triangle. And if we can see that right away, we can save some time. And this is 4. Then 11 minus 4 gives us, this is 7. That's a right angle. Let me write it like this. So is this. So we're looking for the hypotenuse. 3 squared plus 7 squared equals x squared. Not a triple. 9 plus 49 equals x squared. So 58 equals x squared. Square root of 58, it's 2 and 29. No pairs. So we leave it as a square root of 58. How high up a vertical wall? So the distance going up, will a 24-foot ladder reach? So that's the diagonal or hypotenuse. If the foot of the ladder is placed 10 feet from the wall, that's the bottom part. Answer in radical and decimal form. So it's just straight up Pythagorean theorem. X squared plus 10 squared equals 24 squared. That's x squared plus 100 equals 576. Subtract 100 from both sides, get x squared equals 476. Square root, x equals the square root of 476, which I can break down into 2 2's, a 7 and a 17. So I bring out a 2, leave the 7 and 17, which is 119. Or if I just put it in my calculator, I get 21.8 feet approximately. And I wanted it in both, that's not going to show up, radical and decimal forms. Same with number 8. So a baseball diamond is actually a square, so we drew our picture. Then, so we have home, first base, second base, and third base. And each base is 90 feet away from each other. So each side of the square is 90. The pitcher's mound is directly in the middle of home to second. Now that's not actually true, but for our problem it is. How far is the pitcher's mound from home plate? Well, first we got to find this distance, x here, this distance here. So it's just a right triangle. That's our hypotenuse. So it's x squared equals 90 squared plus 90 squared. So we get x squared equals 16,200. If we simplify it, we get 90 root 2. If we take the decimal, we get 127.828. But we need to divide it by 2 because we just want half the distance. We want the distance from the pitcher's mound to home plate, and that's just half. So 90 root 2 divided by 2 is 45 root 2. We just divide these. And 127.28 divided by 2 is 63.64. So that's our radical version, that's our decimal version of the same thing, and that is the Pythagorean theorem.